So in this video, I wanted to give you a quick recap of 6.3. So there's a ton that's going on in this section, so I wanted to give you a reference in addition to Ms. Roberts' videos that you have more examples and more explaining. So the very first part of this section was just converting from logs to exponents. So logs, you don't have stuff memorized. Like you don't know log base 2 of 5. That's just not readily available information. However, I can take a log and convert it into an exponent, which I know more about. For example, you have log base x of 16 equals 4. So this first one on the left, that's how it's read. Log base x of 16 equals 4. So you'll see that I wrote right here in the center of the screen, always start with the base, and then you're going to make this same kind of roller coaster shape because math is like a roller coaster. So the base with logs is the little number at the bottom. Now we know about exponents, so that you know the base already. But start with the base, so I start here with the green part, and then I go through the 4 and through the 16. Let me change my pen. So I start with the base, go through the 4, come through the 16. So I have x to the 4 equals 16. Now it doesn't ask me to do anything with it. The directions in this first part just say to write an equivalent statement. So I'm not doing any solving. I'm just changing it from logs to exponents. Okay, so the next one, log base 4 of x equals 32. So always start with the base and go through the 3 over 2 and then hit the x. So I have 4 to the 3 over 2 equals x. That's my equivalent expression. Now, what if I'm given an exponent and they want me to write a log? So this one is a little different because you have to add in the log part. But then you start with the base and you go in that same direction. So the base for an exponent is the big number. So I go through 1 over 81 and then hit negative 4. So what that means, I'm going to write the 3 first. I did 1 over 81 next equals negative 4. So I take that same order, that same roller coaster loop. Always start with the base, and then as I hit the numbers, I fill them in the next one. So 2 to the 3rd equals 8. I want to convert it to a log, so I have to write out log, start with the base, and do that same roller coaster loop. So I have log base 2 of 8 equals 3. So all they asked me to do was take the log and convert it to exponents, or if they gave me the exponent, convert it to a log. There are the assigned odd problems. However, you need to do a ton of these so that you get in the habit of writing it correctly. If you don't know how to convert a log to an exponent like you did on this left side of the screen, if you don't know how to do that, you cannot continue the rest of the section. So please make sure you have a good grasp on this. All right, so with that being said, well, here's when it matters. They told me to solve these 3 pieces. Now, I just pulled out 3 at number 18. I think it goes all the way to like letter F or something. There's a ton of them. But I just picked out 3 so that you get the idea. I know nothing about logs. Nothing. I don't know what log base 3 of 81 is off the top of my head. So you'll see the note I wrote down at the very bottom of the screen. Any time that you are asked to solve a log, turn it into an exponent because I don't know logs. I do know exponents though. So I'm going to take this thing and convert it to an exponent. But if you remember on the previous screen, I had equals stuff. Well, I'm looking for what it equals. So if I don't know a value, I call that x in math. Start with the base. And then do that backwards loop. So I have 3 to the x equals 81. Okay, so now at least this looks familiar. Now, I still don't really, haven't, I haven't found x or anything, but I'm on the track to finding x. Now, we have a rule that says if the bases match, then you can set the exponents equal. Well, right now I have 3 to the x and 81 to the 1, essentially. Well, those bases don't match, but I can rewrite 81 as something with a base 3. 81 is the same thing as 3 to the 4th, and now that I have the bases the same, 3 and 3, I can set a little equation and let the exponents be equal. So now I'm going to solve x equals 4. Well, there's nothing to solve, and so that is my answer. So in the second example, I have log 3 of 1/3, and I want to solve it. So again, I let it equal x. Start with the base. I'm going to convert it to exponent. So I have 3 to the x equals 1/3. Now again, I have to make the bases match. So on the left I have a base 3. On the right I have base 1/3. With any time you see a fraction, you're going to normally take the denominator, rewrite it to match the base, and then have to do some exponent rules. So that's 3 to the 1. Now, if you remember, we had this property that said if you had a negative exponent, you could take it to the bottom and make it positive, and if it was on the bottom and it was negative, you could bring it to the top. That was from Math102 specifically, but also we mentioned it in the last section. So here I have this thing that's on the bottom, and I want to bring it up to the top, this 3 to the 1. So if I bring it up to the top, I can actually just change the sign of the 1. So I can make that 3 to the negative 1. Now I have the bases are the same, so I'm going to set the exponents equal, and I'll have x equals -1, and it is already solved. Now in the very last one, letter C, which you'll see on the right-hand side, I have log base 6 of the square root of 6. So I want to make an equation, so I'm going to set it equal to x because that's what I'm looking for. Start at the base, do that backwards thing. 6 to the x equals the square root of 6. Any time in Math 110 you see a radical, you convert to an exponent. And we learned that property in class in 6.2, so make sure that you know how to convert radicals to exponents. But this is a 1, and that's an understood 2, so I can rewrite that thing as 1/2, and that one, of course, stays the same as 6 to the x. Now the exponents are equal. The bases are equal, so I can set the exponents equal, and that one is already solved. So those are your 3 answers. Here's another good opportunity to get out a note card to help you learn these properties. So on your index card, copy all 3 of these properties down. Yes, they are in your notes. Yes, we've talked about them a million times, it seems like. But putting them on an index card, the more times you write them, the more likely you are to remember it. So I have the product, quotient, and power rule. Product rule, multiplication inside turns to addition outside. Quotient rule, division inside turns to subtraction outside. Power rule says that if you have a little tiny power, you can bring it down in front of the log. So those are the 3 properties. In the rest of the homework, 65 through 85 in the homework, all of those have to do with these 3 properties. These are the only 3 properties you have for condensing and expanding logs. So in numbers 65 through 76, the directions look a little different in your textbook, but you are expanding these, and that's the way it will be written on the test. You're taking them from 1 log and turning them into 5 or 6 logs. So I'm starting with number 76. I have 1 log p of the cubed root of m to the 5th over kt squared. Now, we just said in the last example that anytime you see a radical, the first thing that needs to happen is it turns to an exponent. So that's a 1, way outside that whole thing. So I'm going to rewrite this as log p of that thing inside all to the 1 over 3 because 3 is the index. So I have the cubed root is the same thing as the 1/3 power. Now I'm going to start asking the same question over and over and over again. What is the overall operation? Well, the first big operation I see is that power. It's got a big giant parenthesis, so I need to do the power rule first. Take care of that 1/3. So I have log p of this thing, and the power rule says that you can take that 1/3 and drop it in the front. So that's my first part. Now it's not expanded, so I have to keep going. Now I look back to the inside of the log and say, well, what's the overall operation? Well, there's a lot of operations happening, but the overall big one is this division bar right here because it's covering the whole thing. So now I need to use the use the quotient rule in the proper order. So I have division inside, and when I use my rule, it's going to be subtraction. So I subtract top minus bottom, and I can't forget that big giant 1/3 out front. Now you do have to put brackets or parentheses around that because that 1/3 is all the way out front. So it has to be, you could technically distribute it to each log. However, I would just leave it all the way out front and just put a parenthesis or a bracket. Now I'm going to look again. So now in this log, what's happening inside? Well, I had power rule, and then this last one I just had was quotient rule. Now within the first log, I see another power. I see that 5. So I'm going to bring the 5 down out front, carry everything down. Now the next log, what operation do I see? Well, I have k times t squared, so I have a product. So I'm going to take the k and the t squared and expand it and turn it into addition. That's what my product rule says. Now again, because that subtraction right here goes to that whole log, I'm going to need a big set of parentheses. So now I go back again and I look at each log. Which log or what operation is going on in each log? So I'm going to look at the first one. 5 log p m. Well, I don't see, there's no power happening, there's nothing being multiplied, so that one actually ends up being done. Now, you don't need to put a check mark. I'm just putting the check mark to show us, yes, it's been done. Now I go to the next one. Log base p of k. I don't see a power, I don't see a quotient, I don't see a product. Those are my only 3 options. So that one's done. And the next one, log p t squared. I do see a power, so I need to bring that 2 down and then carry everything down. And there is my final thing. And I know that everything is done because finally all of the logs are completely expanded out. So there's no more powers, products, or quotients. So with expanding, your only three options are power, product, quotient. Nothing else. All right, so here's my last example. In this example, you're actually using the properties in reverse. So you're taking it from a whole bunch of logs and squishing it all the way down until it's just one log. Again, the directions in your textbooks won't use the actual term condense, but on the test, ones that I want you to shrink all the way down, you'll see the word condense. So like number 77 through 88, all of those, the directions could say condense these logs. So I'm taking them from, in this case, 2 logs, putting it into 1. So it's kind of like I look at each log and I say, okay, well, what's going on? So this first log, I have 1/2 log y p to the 3rd, q to the 4th. So here, the big thing I see is this 1/2 outside. Before I can do anything, I've got to bring that thing up to the exponent. So I'm just rewriting the log, and then I'm going to have that power come up. I'm going to do the same thing with the 2 over 3. Okay, so now I have 2 logs. Well, the thing separating those 2 logs is the subtraction sign. If it's subtraction outside, when it goes inside the log, it turns into the quotient rule. So I'm going to put the first one on top, second one on the bottom, and have one big log y on the outside. And then I can't forget about my exponents. So there is your condensed log. Now you'll see sometimes in the textbook it'll say this or this or this. Sometimes they convert it back to a radical. They try and make it a little bit prettier. But once you get it to 1 log, I am good.